Hello, ma'am. This is Group 19, and we will be discussing supply chain management in quick commerce, focusing specifically on Zepto. So, this is our team. Myself, Ryan, I'll be covering the introduction and the literature review part. Coming to the introduction, quick commerce is a rapidly growing segment in the e-commerce space that focuses on the ultra-fast delivery of goods, typically within 10 to 30 minutes of ordering. This model is designed for small basket purchases, ensuring speed and convenience for customers who want essential delivered almost instantly. The rise of quick commerce has been driven by two main factors, that is, growing consumer demand and pandemic acceleration. People today value their time more than ever and prefer having groceries and daily essentials delivered to their doorsteps in minutes. Coming to the key players in quick commerce, there are several companies which have entered the quick commerce space, ensuring intense competition such as Blinkit, Zepto, Dunzo, Big Basket. But today, our primary focus will be on Zepto, one of the fastest growing names in this space. Zepto was founded in April 2021 in Bombay by two people, which is Adit and Kavelia, who are both Stanford dropouts. What makes Zepto unique is its promise of 10 minutes grocery deliveries achieved through a network of hyper-local dark stores, which are like small warehouses located strategically within the cities to minimize delivery time. The customer places the order on app, then the order is received in the system. The system routes ordering to the nearest or nearest data dark store. Items are picked from the dark store and then packed. Then the delivery agent comes to the dark store, collects the item, and then delivers it to the customer. In just 1 year, Zepto expanded to multiple metro cities like Bombay, Delhi, Bangalore, and Chennai, achieving a valuation of around 900 billion USD. The company competes directly with Blinkit, Swiggy, Instamart, and other venture capitalists for gaining attention. Coming to the literature review, where we analyzed several key studies and articles to understand the dynamics of quick commerce and Zepto's business model. In the first one, just in 10 minutes, a case study on Zepto by Gupta and Pandey. This study examines Zepto's rapid delivery model, highlighting the supply chain strategies and the operational challenges the company faces in maintaining its 10-minute promise. Rise of Quick Commerce in India by Rajakar and Roy. This paper takes a broader look at the emergence of quick commerce in India, analyzing the business models of leading players, including Zepto. Coming to the third paper, Zepto business model, quick commerce success and challenges. This article dives deep into Zepto's unique business model, focusing on how its data-driven supply chain enables ultra-fast deliveries while discussing the challenges of scaling this model. The business model of Zepto, redefining quick commerce by SAR Consult. This report focuses on Zepto's innovative supply chain and logistics strategies, detailing how the company optimizes delivery routes and manages inventory to support its 10-minute delivery promise. The fifth paper, The Zepto Success Story from Startup to Quick Commerce Giant by Marketing Staff. This article talks about the Zepto's meteoric rise from a startup to a leading player in quick commerce, highlighting the critical milestones, funding achievements, and key strategies. The sixth paper, The Zepto's Business Model, Quick Commerce Revenue and Growth Strategy. This is in-depth piece focuses on Zepto's current revenue streams and growth strategies, offering insights into how the company plans to scale and maintain profitable moving forward. Maintain the profitability. Now coming to the seventh one, optimizing last mile delivery, the role of urban consolidation centers. Although not directly about Zepto, this paper provides valuable insights into last mile delivery optimization, a crucial aspect of quick commerce. It discusses how urban consolidation centers can reduce delivery time. The eighth paper, The Impact of Social Media on Pharmaceutical Recalls. While focused on the pharmaceutical industry, this study highlights the power of social media and real time supply chain communications. The ninth paper, Dynamic Coupon Targeting via Batch Deep Reinforcement Learning. This paper explores how AI significantly deep reinforcement learning can optimize coupon targeting in e-commerce, like how the Zepto could adapt to enhance its marketing and loyalty programs. The 10th one, the business model of Zepto, redefining quick commerce. This is an extended analysis of Zepto's approach to redefining quick commerce. It further explores how Zepto uses geospatial data and predictive analysis to optimize inventory and delivery routes. This paper also highlights the Zepto's continuous innovation in logistics to stay ahead in the competitive quick commerce market. The 11th one, the Zepto success story from startup to quick commerce giant. This additional study provides deeper insights into Zepto's success, focusing on customer acquisition strategies, like how Zepto overcame the challenges faced during expansion. The 12th paper, uh, Zepto business model, quick commerce, revenue, and growth strategy. This is in-depth look at Zepto's future strategies, highlights its focus on scaling operations sustainably. It discusses plans to diversify product offerings, optimize delivery networks, and leverage AI-driven analytics for better demand forecasting and inventory management.
Greetings to the teachers. My name is Sanjana Carroll, and I'll be covering the objectives, process flow, and the business model followed by Zepto. Starting off with the objectives, our first objective is to study Zepto's inventory optimization for dark stores, which will be done by analyzing stock levels and demand patterns using ABC classification. Our second objective is to analyze the optimal city tier for new dark stores, which is done by evaluating sales distribution and outlet size. The third is to identify customer buying behavior and pricing strategy, which is done by studying sales distribution across various product categories. And our last objective is to evaluate demand forecasting, for which we'll be using ARIMA, and also to design a dashboard showcasing various analytics like sales trends, demand fluctuations, etc. Coming to the process flow, Zepto follows 5 steps for every order, starting with order placement as its first step, where the consumers place their order via the Zepto app or their website, and the system verifies availability of that particular product in MFCs, abbreviated as micro fulfillment centers, via real time stock updates and AI driven demand prediction. The second step is order processing, where the system assigns the order to the nearest MFCs and also considers factors like distance, stock levels, availability of delivery partners, etc. Here, the payment is processed instantly via the various digital payment gateways available. The third step is inventory management, where the MFCs ensure hyperlocal inventory is stocked based on demand patterns, and real-time tracking optimizes stock levels, and this ensures that wastage is minimized and we don't run into out of stock scenarios. The fourth step is picking and packaging, where the order is sent to warehouse staff or automated packers for quick selection. And there's also a mechanism of barcode scanning, which ensures that the correct order is picked. And for the final step, which is last mile delivery, the delivery partners are assigned dynamically, the routes are optimized, live tracking of the product or order is enabled, and in case of failed deliveries, automated reattempts are triggered. The same process flow and the 5 steps are depicted in this image shown. Before we move on to the business model, there are three questions which Zepto analyzes and um, answered before they formulated the business model. The first being what do customers want, which was quick deliveries and high discounts, of course. What are customers willing to pay for, which was convenience. And the third question being what options are available in the market, which was Swiggy, Instamart, BB Now from Big Basket, etc. So, after considering these things, before setting up a dark store in a particular locality, Zepto analyzes three key factors, which is the first one being the buying patterns of the consumers in that area, the purchase frequency, that is, how frequently do the consumers of that particular area purchase those products, and the total spending power or capacity of the consumers in that area. So, as we can see in this image here, which shows the super quick dispatch by Zepto, this image shows how Zepto is able to fulfill its 10-minute delivery promise. And we can see that the order is placed and the order is dispatched within 60 seconds or 1 minute. And a solid 9 minutes is allotted for the order to go from a dispatched state to a delivered state. And this particularly ensures that Zepto is able to fulfill its 10-minute delivery promise. Coming to the three different strategies that Zepto follows, the first one being location engineering, where Zepto studies that particular location, the traffic routes, the real estate prices, etc., before setting up a dark store. And the second strategy is the dark store model. That is, they set up mini warehouses or the dark stores strategically such that they can deliver within a 3 kilometer radius, and they implement the PPB, which is picking, packaging, and bagging under 60 seconds. So, under picking, there are employees, or even these days, automated robots or cobots, which they call, which goes around the dark store, enabling the picking process. Under packaging, the items are quickly packaged into the bags, and bagging, the packaged items are handed over to the delivery agents. And so this gives a solid 6 to 10 minutes for the delivery agents to deliver the particular products, which is much less when you compare it to the usual other competitors available in the market, which take 15 to 20 minutes to deliver the products. And even recently, Mr. Adat, the co-founder of Zepto, told that the median delivery of a particular Zepto order is 8 minutes 47 seconds. So their median delivery is much lesser than the usual delivery of other competitors. And the third strategy is hyper focus on speed and retention. So while the other quick commerce platforms are focusing only on the availability of products or high discounts, Zepto primarily focuses on the speed of the delivery, which ensures a massive retention rate of customers and also ensures a loyal customer base, because when a customer initially for the first time tries out Zepto, they are truly impressed by how quick the deliveries are done. And even though they are getting probably a little better discount in other quick commerce platforms, they would choose to have this convenience and ease of getting your products under 10 minutes than wait for 20 to 25 minutes in other platforms. So this gives Zepto a higher up in the market, and we can also see that this is the Zepto delivery time calculation frame. And here we can see there are two major delays which are faced by the other quick commerce platforms, which is cut down by Zepto. That's the assignment delay, where that's the time required to assign a particular delivery partner, and the first mile delay. That's the time taken by the delivery partner to reach the dark store to pick up the order. And these two delays are pushed out of the system in Zepto business model. And there are only two timing factors which Zepto looks into: the preparation time, that's the PPB, picking, packaging, and bagging, and the last mile delivery, that's about 6 to 10 minutes for the delivery partner to pick up the baggage and deliver it to our home.
Good morning, ma'am. I am Nishant, and today I will be explaining the code and the results that we have obtained. So, today I will be presenting insights from our data analysis, basically on demand forecasting, inventory classification, and sales distribution trends that we have performed. So essentially, this analysis is basically used in optimizing inventory, improving management, and ensuring better decision making in that of the supply chain. So our first task, or the first objective first, was actually demand forecasting. So again, what is the point of demand forecasting? It is to predict future sales trends based on historical data. So in this case, we use ARIMA, which is an auto-regressive integrated moving average model, and we have imported ARIMA from the stats model library. So essentially, we use this model and again aggregated sales over time to identify trends and patterns so that we can optimize inventory accordingly. So this is the code that we have done. And then this graph explains the demand trend over time, total demand on the y-axis, and then the particular time duration or year on the x-axis. And this is how the sales, essentially the sales steeply decrease after 2022 January. So this is the analytics that we have done based on the given data set. So, and using Arima, we see that the sales essentially get stabilized over the next few years. So this is the result that we're getting that we have obtained. Thus, we can use this result to actually optimize inventory accordingly. So, and the next one we will next objective that is met is actually inventory classification. So for inventory classification, we use this technique called ABC classification that essentially helps us to prioritize inventory based on sales contribution, ensuring high value items are actually stocked optimally. So essentially, based on cumulative sales, what we do in this case is all products were classified into three categories. We have A, B, and C. A is essentially the top 80 percentage of sales, which is essentially high priority, and these are the products that we need maximum stock of. B is the next 15% of sales, the moderate priority and needs balanced stock, whereas C is low priority and can have minimal stock. So that is ABC classification, and that this is the code for it. And then as we see, you have particular items with item identifiers. Item identifiers tell you which item they are. So thus here we see that ABC category and stock at max levels, which means that these are the items that we need to keep maximum stock of, which is present in our data set. And to give us a visual idea, again we see number of products and cumulative sales, and we see all are actually A category, which means that they need to be high priority. So the next one is sales distribution by outlet, so that this data can be used for expansion. Where exactly do we open new outlets? So in this case, we see that sales distribution by outlet types. So we have three different location types. First, we have metro cities, then we have tier 1 cities and tier 2 cities. So according to sales, we see that tier 1 cities actually generate the most sales. Thus, ideally, we should be opening new stores in tier 1 type of cities to increase revenue. So again, also sales distribution by outlet size. So we have two types of outlets in this data set. We have medium and small scale outlets. So we see that both of them approximately generate the same amount of sales. Thus, it doesn't really matter what kind of store you open, but economically, opening small outlet sizes are more efficient, but lesser inventory. And then the next one would be sales distribution by product type. So which product actually brings in the most value or the most sales to that particular outlet? We see first comes our snacks, which generates the most revenue. Next, second is personal care, and third is beverages. So the product categories are given, and the top six product categories are these according to the graph and the data set that we have obtained. And also we've done analysis using fat content, because we see that people generally buy more low fat items due to health consciousness, and then that reflects in the total sales even though it's just a slight increase. Also build a dynamic dashboard. As you can see, we have the total sales column, we have average sales, we have number of items, we have average rating, and then we have fat content, and we have various types of item types. We have fruits, snacks, household items, frozen foods, dairies, etc., and all the other stuff that's actually present in a data set. We also have outlet location type related sales. We have tier 1, tier 2, and tier 3 cities respectively, and also outlet sizes medium, small, and high, the various analytics involved with them, and also outlet type and the various total sales number of items and their split up related to that. And so here, when I say a dynamic dashboard, we can essentially change the, let's say I only want tier 1 cities, the sales of that. So we see that the values dynamically change. And now let's say, for example, I need only tier 2 cities, and we see that the values automatically change for all. This is what I mean by saying a dynamic dashboard. And I can also change it to tier 3, and we see the values similarly change.
now I'm going to be covering two things. One is the report, which is of 4 pages, and another thing is the data set. So, what's our topic essentially is it's supply chain management in quick commerce, and especially we are doing study on Zepto particularly, and the data set will belong to Zepto itself, and we got it from productscrape.com, which is a place where you get multiple data sets. So, what quick commerce essentially means is that it's basically trying to deliver groceries in 10 to 30 minutes. And one of the key players is Zepto. And apart from Zepto, there are also other key players like Blinkit or Swiggy, Instamart, etc. So, the main thing about this business is that it needs to have dark stores, very hyper local to the customers, which are like generally ordering more, like based on the demand. So all that will generally happen through a data driven supply chain to make sure it meets the growing demand of the customers. So this study, the main aim is to examine its strategies through about the inventory or the expansion and demand forecasting, and at the same time we are also analyzing consumer behavior to enhance the efficiency of it. So we in essence we have like two main objectives. I mean the two objectives. So one is the primary objective and one is secondary objective. In primary objectives we have like two sub objectives, which is like to examine Zepto's inventory optimization strategies for dark stores, to analyze the most suitable city tier for establishing new dark stores. In secondary objectives, we have something to forecast demand and develop a data-driven dashboards to identify customer buying behavior and accessing price strategies. So based on this is how we are going to approach our methodology or our implementation, etc. That's what our goal is. So the approach how we found out is that we are going to study both qualitative and quantitative analysis to assess the Zepto's supply chain exactly based on the inventory data or the last mile delivery. So this data driven approach we have involves doing demand forecasting and understanding the inventory, and we are also going to look into do qualitative studies by looking into case studies of other quick commerce businesses, etc. So what is the procedure? First is data collection. So as I told you, I'm going to show you a data set. So that there we are going to analyze the operational data of the Zepto, and then we are going to do the relevant literature for it. And the second thing is analysis. So what analysis are we going to do? We are going to do demand forecasting using Arima. Third thing is visualization. We are going to create a dashboards and do real-time analytics using a Power BI. It's as simple as that. So, project execution. So the main thing of our design thing is creating a scalable model to adapt to different city types and product categories. So key KPIs was set to measure supply chain efficiency, delivery speed, and customer satisfaction. Three main focuses. So the study followed a phased approach in general. That is the literature review, data modeling, dashboard development. So that's a general way of how you do it. So the demand forecasting model was validating against the historical data to ensure accuracy, and interactive dashboards were developed using the same data. The data which I'm going to show you after this, and based on that is where your strategic decision making comes, your inventory management simulation, etc. So the dashboard was created to visualize the real time analytics of it. So what all tools we used? We used Python because that's where the programming language and language kicks in terms of what we need to do. Second is Power BI for the dashboards, and pandas, MATLAB, all this Cbon, stats model, all this we have used for during the data, I mean analysis part, the visualization part, etc. So what techniques have we used? So advanced data mining techniques to cover the sales insights. So as I mentioned before, the Arima for demand forecasting and data visualization for performance tracking. So what are the final results we got? So these are the 4 graphs you can see here. One is sales by fat content. So how much sales you're getting? Like the low fat items are getting sold more, or like the high fat content is getting sold more. These are the factors which you need to consider. And one more thing is the demand forecasting, which I told you using the Arima. So how the demand is growing or decreasing, year by year, how it is, all these aspects. and one more is sales distribution by that specific outlet of Zepto. So how the outlet is, etc., etc. So this analysis highlights the snacks is the top selling category, emphasizing the need for optimized inventory. So tier one cities emerge as an expenditure area due to the demand it has. So that is the final answer which we are coming to through the analysis we have made. We are telling according to the analysis that tier one cities have probably a better scope for it to increase or expand, because that's where most of the customers come in, that's where most of the demand is there. Like people from that place is they're ordering way more than tier 2 or tier 3 cities or other towns, villages, etc. So there's one more thing which we observed is that there's preference for low fat products, reflecting a shift towards healthier choices. So Zepto can probably bring in products based on that or something. So this is one kind of analysis, what kind of products are being sold, so that we can get to know what kind of inventory we can get in, what kind of products we can get in order to meet the customer demand. This is one way of understanding it. There's one more graph which is sales distribution by product type. So based on which product is getting sold, where we'll arrange the inventory also in the same way. So that is one more way of looking into it. So before I go into the conclusion, I will show you the data set we used. So as I told you, this is from the product stream data set, productstream.com, and then it productdatascape.com, and it has different this thing here attributes, like the item fat content, item identifier, item type, outlet establishment year, outlet identifier, outlet location type, outlet size. So one of the main things is to understand is, first of all, the back stores which are there. So here it's mentioned as outlet, the dark stores. Those outlets are present where? In tier 1 city or metro cities, tier 2 cities, etc., to understand whether the demand is high there or low there. Do we need more dark stores? Understanding what we need to expand, all that. And to also understand where the outlets are functioning, where the outlets are not functioning in the tier 1, in the metro. So we can also understand where exactly the customer demand is happening. So the data set is going to help us in understanding all that. And there's item type, what items are getting sold more in what place. Like probably in tier 1 cities some sort of items might be getting sold more, in tier 2 cities some sort of items might be getting sold more. So depending on the customer demand on that particular cities, on that outlets, based on that is how you have to manage the inventory. You can't like standardize an inventory of like overall these sales are happening more, so you can't just put it like that. So you need to analyze specifically for that outlet, specifically for the city. And this data is basically going to help that do it pretty faster, like because the outlets and the things related to what product categories are mentioned clearly here, and what is the size of the outlet, how much inventory can be kept in it, the item visibility of it, the item weight, because while delivering also it might become an issue how much the weight is, right? Or if you're seeing vegetables or grocery, weight is a very essential thing. And also sales numbers mentioned for that particular outlet, for that particular product, in order to understand how much sales has happened throughout, right? So if you understand the sales, then you can understand which product is sold more, which is sold less, and the rating of it. So if the rating is low, then you can say that this product keeping it more might not help because customers are not liking it, or is the delivery happening on time. All these aspects you can understand because of rating. If rating is low, you will understand that there's some problem happening either in the delivery side or the product side or supply side. So you need to understand the rating is what will bring to that thing. So this is essentially the data set. And our conclusion is, this research highlights the role of data driven decision making, as we told, in supply chain resilience and operational efficiency in quick commerce. So this scalable model offers a blueprint for understanding the hyper local delivery players based on how I told you regarding the data set, understanding the inventory management, demand forecasting, and customer centric strategies. So the personal reflection, what I got through this project enhanced our understanding of data analytics tools, especially in the real world example. So it strengthened our teamwork, communication, problem solving skills for it, understanding deep knowledge of data visualization or forecasting, etc. So you can scan the QR code for the demonstration of the video exactly, And we are the team members. I'm Siddharth presenting this part exactly. Thank you.